Greetings humans, Ryan Lemon here, going to do some mathematics with you. Fun stuff, am I right? Okay, relations. You've already got a working definition for them. It's simply a matching of a couple of numbers together. So you've got a pairing of numbers like 5 with 7 or 3 with 8. It doesn't matter, it's just the mapping of two numbers, one to the next. And the first of which is called the domain, and the second is the range. Whatever it maps to is the range. Now some people talk about these in different terms. Some people say input, which is synonymous with domain, and they say output for the resulting number. Again, I've color coordinated so that you know domain is the same as input, range is the same as output. Cool beans. Let's do a quick example. Okay, so suppose you have the relation that maps 5 with 0, 6 matches with 0, 7 with 6, 8 maps to 8, and 8 again maps with 10. The members of the domain are the members of the first number, or the input. And we'll make this eventually synonymous with the x, as an XY pairing, but we'll talk about that later. Right now, we can see 5, 6, 7, and 8 are the members of the domain. And we're not going to write 8 twice because we're just going to represent all the numbers that are the domain. With the range, you've got this output of 0, this output of 0, so really just 0, 6, 8, and 10. So to represent the range, 0, you don't have to write it twice, 6, 8, and 10. It's that simple. We're just identifying the domain and the range. We most frequently see these ordered pairs written in the form of x, y, where x is the member of the domain and y is the member of the range. Cool beans. Let's do another quick example. Before we do another example, we need to know exactly what it means to have a function. A function is a specific type of relation where each input, or member of the domain, maps or matches to exactly one output, or member of the range. Now, what does this mean? Well, here is an example of a function. Notice that each one of these inputs matches to just one output. 6 with 7. 8 is a different input, matches to a different output. Notice that 7 is not the same as 9. So far, each member of the domain, or each input, just maps to one specific output. 10, a different number, maps to a different number, 11. Cool. Now what's not a function? Something that would not be a function, not a function, would be something like this. 6 matching with 8, maybe 7 matching with 9, and 6 matching with 10. Notice what's happened here. We have, again going to their definition up here, a relation where each input matches with exactly one output. Here's an input of 6 that matches with 8. That's all well and good, but I hope we don't have 6 again, and I hope for sure it doesn't match with something different. So here we have a member of the domain, an input that matches to two different, 1 and 2, two different outputs. Not exactly one output, but the 6 goes with the 8, and the 6 maps with the 10. So this is defined as not a function. Let's take a look at these two examples. Can you tell whether each is a function or not? Looking at the first, you have 0 matching with 0. That's fine. 1 matching with 1, that's fine. But what we have to be careful of is when we have the same input, because if it goes to a different output, then it's not a function. Because remember, a function is a relation where each input matches with just one unique output. So in this case, you can see that you have an input of 1, but it's got 1, 2 different outputs. So this is not a function. Indeed. Let's look at the second example. Go ahead and see if you can figure that out on your own. The only time you have to be careful is when you have 2 of the same input. Because if one of these goes to a different number, then you don't have the definition of a function. A function is a relation where each input maps to exactly one output. But you have the number 3 here, and you have a different number, 2, over here. So again, this is one output. This is a different output. So therefore, this is also not a function. How about this visual representation? Is this relation a function? You don't have to list all the points, but I'll do it for you. It's 1 with 5. Here's 3, 1. Here's 4, -2. 8, 1. And 6, 3. Is this relation a function? I'm going to say yes, because if you notice, all these points have a different input. And it doesn't matter the output as long as all of these points, their domain, is different. There's no chance of having a domain, member of the domain, that has 2 outputs for y. Now, what would not be a function? What's not a function in this case? If we came in and we represented this point here. Notice it's the point 4, 0. So we have to be careful because we have 2 points that have 4 as an input. Notice here, this point is 4, 2. This point is 4, 0. The member of this range is 0. Here's a member of the range as -2. That would be good, except for it comes from having an input of 4. Each member of the domain must match with just one member of the range to be a function. So since we have 4 going with 0 and then 4 again going with -2, a different number, this is not a function. And we know because it passes the vertical line test. If I can draw a vertical line and I hit 2 points, then it's not a function because it fails the vertical line test. Every vertical line you draw should only go through 1 point. If it goes through 2, then of course it fails the vertical line test because you have something that occupies the same space on the x-axis. All right, have fun. Do your homework. Illy.